Okay, before we dive into any new material, I just wanted to make a couple comments on the homework. For homework number 9, this right here, hyperbolic sine, is just a new type of function. You don't actually need to know anything about what it is, but it's defined in terms of e's. And so you can take its derivative once you know how to take derivatives of e. So that was why I put that on this assignment here. So obviously feel free to Google it if you're interested. But for number 7 in particular, and like number 9, we're going to have some properties of logarithms that might be useful. So it says here, for some, it may be easier to apply logarithm properties before differentiating. So I want to remind you of things like if you have log of natural log or log, it doesn't matter, log of some expression and it's square rooted, that's the same thing as thinking of it as a to the 1/2 power, right? And powers have this property of logarithms that they are the same thing as coefficients. So I could use this as a coefficient instead of an exponent. And so in terms of taking a derivative, it's much easier to take a derivative of a coefficient, right? Coefficient just stays out front and you just take the derivative of what follows. That's much easier than taking the derivative of a function and a power within a logarithm, right? So that might be a useful property, say here or here. And further, in some of these ones, like this one has a quotient in it, we also have this property that if we have a logarithm of, say, a over b, that's going to be equal to the logarithm of a minus the logarithm of b, right? So we have all these properties. So you should look up, remind yourself of these logarithm properties and see how you can use them for 7, 8, 9. I think that's most of them. Just be careful not to make up your own rules for some of these logarithms. So that was my first comment. And then the other one was for homework 10. If we could just scroll down a little bit. Now we're skipping over the inverse trig derivatives until Monday, so we'll talk about these on Monday, but I wanted to just mention that here are the formulas that we're going to prove them on Monday. These are the sort of generalized versions of these. So in other words, if I wanted to find the derivative of just inverse sine of x, that's just 1 over the square root of 1 minus x squared. Okay, and again, we're going to prove that in class. But notice here they're saying if you have some inside function u, it would be 1 over the square root of 1 minus u squared, so you're putting that u in, and then times u prime. So that's using the chain rule. So all of these formulas are already written in terms of their sort of generalized form. So when you are asked for homework 10, let's just scroll down to that for a minute. When you're asked to find the derivative for number 5 and number 10, you have an arctan of 2x here. So your u is 2x, and you have an arcsine of x over 2, which you could think of as 1/2 x, so your u is 1/2 x. You can go ahead and apply those formulas from the page before, even though we haven't proved them. So homework 10 is also due on Monday, and so I think you should be able to do everything on that by yourself now.